Example 6. By method of induction, prove that 5 to the power of 2n minus 1 is divisible by 6 for all n belongs to n. So, induction method, let us try to prove for n equals to 1 first method. So, for n is equals to 1, 5 to the power of 2n minus 1 is nothing but 5 square minus 1. That is equals to 24, and this is 4 multiplied by 6. That implies this number is divisible by 6. That means 5 power 2n minus 1 is divisible by 6, and that implies P1 is true. P1 is true. That means the statement is true for n equals to 1. So we assume now the statement be true for, let P k is be true. Let the statement be true for k values. It implies that 5 to the power of 2k minus 1 is divisible by 6. Is divisible by 6, which implies 5 to the power of 2k minus 1 is equals to 6 into some integral value. M belongs to Z. Z is integer set. Okay, 6 multiple. That implies 5 to the power of 2k is equals to 6m plus 1. You call this as condition 1. Now we have to prove the statement pk plus 1 is true. Okay, that is, we have to prove 5 to the power of 2 times k plus 1 minus 1 is divisible by 6. So consider 5 to the power of 2 times of k plus 1 minus 1 can be written it as 5 to the power of 2k plus 2 minus 1. That can be written as 5 square into 5 power 2k minus 1. But from condition 1, 5 power 2k can be replaced by 6m plus 1. This is 25 times 6m plus 1 minus 1. Clearly, the simplification gives us 6 times 25m, okay, plus 25 minus 1. That will become 24. Overall, you have 6 common, 25m plus 4. So, it is a multiple of 6. So, since it is a multiple of 6, left hand side term is a multiple of 6. So, that means 5 to the power of 2 times k plus 1 minus 1 is divisible by 6, which implies statement is true, p plus 1 is true. Statement is true for k plus 1, and that implies Pn is true. Okay, for all n belongs to n by mathematical induction. Hence, the proof.